Natural Resources Heritage Program, where he focuses on biodiversity conservation. In 1994, he founded Project Owlet, a continental network of migrant northern saw-whet owl banding stations. He also directs the Central Appalachian Goshawk Project and is a co-founder for the Northeast Motus Collaboration. He appears regularly on Maryland Public Television, Outdoor Maryland, and has also been interviewed and heard on National Geographic Today, on National Public Radio's Morning Edition, and on Living on Earth. Thank you for being here with us today, Dave. And with that, I will hand the presentation over to you.
So welcome, everybody. I'd like to title this Caught in a Snowstorm that started in 2013 and it's continued ever since. Want to introduce a couple of other people that are real important to this. Scott Weidensaul up in the upper left, Tom McDonald, the upper right, and Norm Smith from the Boston area. Norman and Tom McDonald are probably the two most prolific snowy owl banders in the eastern United States. Norman just retired from Mass Audubon, and he has been moving snowy owls away from Logan Airport for conservation purposes, basically to reduce airstrike hazards and then also to conserve the owls. And the three of us, four of us actually, are part of the International Snowy Owl Working Group, primarily because of the success we've had with Project SNOWstorm. Snowy owls come down to the northeastern United States, the central prairies annually. And in a typical year, you'll get a distribution of snowy owls in the Northeast here that looks something like this. This is January of 2013 and is pretty typical of most years. And note for the folks that are interested in New Jersey that they're just barely getting down to New Jersey. They're usually much further north. They like the snow, unlike all of us mid-Atlantic people that try and avoid the snow. But in December through the spring of 2014, the situation was very different. There was a massive influx of snowy owls from the north. This is what an eBird map looks like for just December of 2013, 11 months after the last image. The eruption was historic. Hundreds and hundreds and really thousands of snowy owls came down into eastern and central North America. Birds got out to Bermuda. They got down to Florida. A lot of places snowy owls had never been encountered or seen before. And to give you an idea of the magnitude of this, look at down in the lower left there, Christmas bird count numbers, where in the Christmas bird count for 2013-2014, over 600 snowy owls were reported on the bird count, as opposed to the previous high year, which was in the 1970s, where they got up to 250. We like to say that when we started this, we were talking to people, we would never see an eruption of this magnitude in our lives again. We really don't expect this to be replicated. If we see something like this again, then we have to really start working hard to try and explain it. This is really driven by lemmings. The reason we had all these snowy owls in 2013 was up in the Ungava Peninsula and maybe a few other parts of Canada, there was a huge lemming population increase. Lemmings are cyclical. About every 4 years, they go through highs and then they crash. And snowy owls rely on lemmings to produce their young. If they do not find a lemming peak, they don't breed. And in the summer of 2013, there was an amazing lemming peak. This nest with 4 eggs there is lined with something like 73 or 75 lemmings. So the fridge was full that summer. And as a result, we had many, many snowy owls come south into the States here. And when this happened, we realized that it was an opportunity that similar to other collaborative efforts we've done, like Project OwlNet, we couldn't skip. I called Scott one day and I said, have you noticed what's going on? And he says, yeah. And it's like, Scott, we need to organize and do something about this because it's just too good a thing to let go. And we have an opportunity here to learn a lot about what snowy owls do during the winter time down here in the States. So in a matter of a few days, we put a proposal together. We got together with folks from Cellular Tracking Technologies, which is now headquartered out of Cape May, and put this proposal together and created Project SNOWstorm. You can go to the internet now. It's www.projectsnowstorm.org. See all our presence. We used a very different model than most people would do. In academia or research, you write a proposal, you seek funding, and it takes a long time to get a project put together. We put this project together rather rapidly by gathering people with different talents. And Project SNOWstorm really has several elements to it. The one that has proven to be the most popular and the most productive is we put cell phones on the back of snowy owls, cell phones with a little solar panel on them that allows us to study their movements. And initially we were just looking at winter behavior. The next part was to get all our banders together so that we could collect data in the same way and make it easy to analyze and put together via collaboration. You know, how do you measure the owl? What feather samples or blood samples do you take? And got everybody on the same plane and doing the same thing. We organized veterinarians. The Maryland State Wildlife vet, who is Cindy Driscoll, put all of our vet team together. I called her one day and I said, Cindy, what you doing? You want a little distraction for the winter here? Because when you have this many owls floating around the Northeast, there are going to be owls that don't make it, that die. And by collecting those owls and running them through, again, a routine, standardized necropsy approach, we stood to learn a lot about why they were dying. You know, one of the rumors that we've been trying to put down is that snowy owls, when they come down here, they're starving. It's because of food scarcity in the north. And that's a myth. And the data that Project SNOWstorm has collected now pretty much it can put that to bed and say, no, they're not starving. You know, yes, some birds do, but the bulk of them are in very good condition. So we had the vet team on board. Then because we were going to be banding and snowy owls are very photogenic, it's like, well, people might, you know, not really like us going out to trap an owl and put a band on it. And they might sit there and say, well, you know, as soon as you trap the owl, it's going to leave. And our opportunity to watch it or to take photos of it will be reduced by that. And so we said, well, let's, now that everybody has digital cameras and big lenses, let's have these people help us, because if they take the right photos with spread wings and tails, we can assign sex and age to these owls and look at things like, are they assorting with males going to different areas and females and adults going to different areas than young birds. So we put together a way of collecting geotagged photos and images. This became popular very quickly. And when we were putting it together, social media was trying to take over. And some of the people on our team wanted to announce it before we really had all the details put together, before we had the web pages up. And it was amazing the interest in people in getting together and collaborating to do this. So what we ended up with now is a very large team. Everybody brings different perspectives and talents, everything from a web designer that gives us a very good web and social presence, to the veterinarians, to the technology side for CTT. And that's really what it took to make this work, is a large bunch of people who checked their egos at the door and said, we're going to work together for bettering what we understand about snowy owls and the conservation of snowy owls in the long term. So this is crowdfunded. That's where we break a lot of the rules of typical research, where you write a grant and you put it to grantors. We started putting this together in early December, and by late December, we'd raised $20,000 in seed money, and we set a goal of raising another $20,000 or so before we were done. And it worked really well. The campaign reached its goal pretty quickly. And over the years that Project Snowstorm has been in working now, we've managed to raise over $250,000 via crowdfunding to put back into research on snowy owls. Now, while this sounds different and innovative, getting together and collaborating, people have done this in the past. Back in my home state in the 1970 eruption, Fran Hammerstrom and some people there tried to do the same thing, but this was the 1970s. Nobody had a personal computer on their desk. They did their work on movements and distribution of snowy owls in that eruption via telephone and postcards, kind of the old way. So while collaborating is not new, what we did is take advantage of social media and the technology that we have available to us now to take it a step further. Most of the donations are via small donations, people on our crowdfunding, and then the other part of it is sponsorships, like what TNC did when they sponsored Higbee and Hereford. And the money going out is primarily for things like our transmitters. The transmitters are not inexpensive. They used to cost us about $3,000 a piece, plus the data time. And then there's, the travel to get the trapping done. There's a little bit of administration, a little bit to run the website. But primarily, most of the money that we've raised has gone into the hardware that we've been putting on the backs of these owls. And to say that we were successful is, to us, a small understatement. It has been wildly distributed via things like professional magazines, the Wildlife Society, a lot of media, web presentations like we're doing here. So Project Snowstorm has worked out beyond our wildest dreams. The primary objective was to study the winter movements in ecology and habitat selection of snowy owls, to see what they do while they're down here, sharing the space with us in the mid-Atlantic or the Northeast or the Great Lakes states. And the way we did that was this little bit of it's essentially a cell phone. It's got a GPS in it. It's got a data bank where you save the data. It's got a solar panel to recharge the battery, and it talks to the same network that you send text messages to. And these weigh about 3% or less of the bird's body weight when we put them on. People always ask, well, how do you catch a snowy owl? And it's like, well, that's one of the secrets that, we try and keep to a small group of people. But it's relatively simple. We use a big bow net. It's like a couple of C's with netting and springs and a radio trigger. The bait is usually something like a pigeon inside a cage so it doesn't get caught or hurt in the trapping operation. Another way of catching a snowy owl is a much older technology that came out of India a long time ago called the Balsa Tree, where, again, you put your bait organism, oftentimes things like Russian hamsters or pigeons, in a little cage with a bunch of nooses on it. The snowy owl will land on it, walk around, and get its foot caught in the noose. Once you have it, then you do your standard banding routine. You add a band to it, you weigh it, you measure it. We take some feather samples. When someone has the skills to take a blood sample, we'll take a blood sample and send it to the vets. We've now been doing this for 8 winters. And I want to show you a little bit of what we're getting out of it here. To date, we've deployed 92 transmitters. I did not update this to say 92 because COVID slowed us down, and this year there's only 2 additions. This is really a slide from a year ago. Roughly 50-50 between males and females. All those little snowy owl icons give you an idea how widespread we are. We have marked owls as far west as North Dakota. as far south as Maryland and as far north as northeast as Maine. And from an age standpoint, about half of them are juveniles. Another 16 were subadults, really not old enough to breed yet. And 31 of them have been full adult owls. It gives us a really good sample to look at what these birds do. These transmitters are incredible in their accuracy because of the GPS end of them. And we get locations that are accurate to a couple of meters. And here's an example of what the data looks like from one of these owls. This is one of Norman Smith's owls that was marked up at Logan Airport. And the bird would come and roost around the edges of Logan. That's the sort of red starlight icons there are really day roosts where the bird didn't move much. The nighttime movements are the blue lines. And you can see what this bird would do is roost on the southwest corner of the airport most of the day. And then when it got dark, he'd go over across the harbor to warehouse districts where he could pick up rats and pigeons and a variety of prey items, or oftentimes they take aquatic organisms, ducks and loons and things out of the harbor. But this bird was primarily a terrestrial forager. Here's another thing that we pretty much kind of knew that owls did, but nobody really had data to prove it. They have no fear of ice and floating on ice. And this is eastern Lake Erie, where owls would go out and once the ice floes started to form, they'd sit on the ice. And these long chains of points that are just spread out, that's an owl floating on the ice at night. Here's another owl floating on the ice in the daytime. And one of the little neat things of science is how the things we're doing mix with other people. We're now letting a researcher from the University of Minnesota Duluth, who's interested in ice dynamics on the Great Lakes, when he saw some of these tracks, he realized that there's a perfect way to study how ice flows move about the lakes by looking at snowy owl tracks and taking the data and then matching it to the studies he's doing on winter ice movements across the Great Lakes. Now here's one of your owls that was marked courtesy of the donation from TNC in New Jersey. That's Higbee. It was a juvenile male. It was originally banded down here at Higbee Beach. After it was released, it made a tour up the west side of the peninsula and then over to the wetlands here behind Hereford Inlet, where it spent most of its time. It took a little bit of a run down the coast here and decided that it didn't like all the buildings and I suppose the seaside aspect of the seashore, and went back up into the marshes behind Hereford Inlet. That young male eventually succumbed to a winter storm. It was a pretty serious northeaster. We've lost several birds to northeasters over the winters. And so he made it for a month and a half or 2 months before the weather got him. And then the next owl here is we recovered Higbee's transmitter, made sure that it was okay and operating. And Mike Lanzone from CTT trapped another bird near Hereford Inlet and put the transmitter back on him. And you can see he pretty much likes the same area behind the inlet. I think both of those birds were primarily foraging on waterfowl, chasing the ducks and things that they could get behind the coastal strand there. He eventually was struck by a vehicle. We had to dig his carcass out of a snow bank, and it was a real challenge to find him, but the transmitter was exposed enough to the sun that it kept working, and they eventually found him and had to dig him out of a real frozen snowbank. Now, these owls have, incredible life histories. These are two owls that we marked in the Upper Peninsula of Michigan. And there's an old saying about good fences. These two birds really knew the limits of their area, and they divvied up the habitat, sitting up there probably eating things like meadow voles and rabbits throughout the winter. And to give you an idea of the scale of what we're looking at here, That little green line is a mile. So they had relatively restricted home ranges during the winter and kept to their own areas, and occasionally would make a little trip somewhere else, but they really focused on this area of old fields and pasture for the winter that they were up there in the UP. This is a bird called Baltimore, which we're going to talk a little bit more about, but it shows you how you can look at these movements between day and night. And one of the things we learned early on is we kept seeing things like this, and they really, in the coastal zone here on the mid-Atlantic, focus on these open waters behind the barrier beaches, probably hunting waterfowl. But when they kept going to this same spot throughout the night, we wondered what's going on. Well, the neat thing is you lay these locations over Google Earth and then you zoom in. And if we could turn this off, what's right underneath that little laser cursor there is a channel marker. And what the bird would do as it was hunting would go sit on the channel marker and watch for ducks. And when it saw a duck that it thought was a likely candidate to give tail chase, off it would go. But that's how precise the locations we can get from the GPS GSM transmitters that we're putting on the back of the owls. We've had other opportunities here as we go. Some of the owls we've caught more than one winter. Baltimore, which will be the subject of a little video after I'm done with my presentation here, was originally caught in an airport in Baltimore, and it was near the end of the season. He was a young male. His weight was right on the margin of putting a transmitter on, and by that time, in 2014, the first year that Project SNOWstorm was in existence, we had put a fair number of transmitters on males. So we said, no, we'll take a pass because we got a lot of juvenile males. Well, turns out 12 months later, he came back to the same airport, was caught the same way by Wildlife Services, who does the wildlife control at the airport. And at that point, we had a donation from the Baltimore Bird Club, and I was trying to find an owl to put a transmitter on using their donation. And Baltimore was back. He was an adult owl. He made it through the mortality trap of young birds, became a candidate to put a transmitter on. And those two wing images are both of Baltimore. And you can see how as they molt, they change. And when we've had these opportunities, it's helped us learn better how we go about aging owls. Well, these big white owls that everybody finds so interesting, they have wings and they go places. And when we started, all we wanted to do was look at winter ecology as they're moving about the mid-Atlantic. And we decided that, it'd be nice if we got stuff back from the north, but we didn't expect that. We thought that that would be really asking for too much. Well, turned out we've gotten wonderful surprises, and we've had a lot of birds come back to us from trips to the Arctic. Now, these transmitters can store 100 to 200,000 points. So when they go to the Arctic, they go out of the cell phone zone and we lose touch with them. But when they come back the following winter, they dump thousands of points, usually between 15 and 20,000 points per data dump when they come back. So we've been fortunate in that 24 different owls have come back to us. We've got summering locations for 31 instances, so we can really look at how they use the Arctic in the summertime, and nobody else has data that is this detailed. It's really been one of the great additions that came from this collaboration. I'm going to show you a track of one of the owls, Dakota. As it goes up north, you see the little square there. That's roughly where it's centered. And when you zoom in on that, you get something that looks like this. And the interesting thing to us is when we start seeing concentrations of points. We get a point about every 30 minutes when they're in the Arctic. And if you zoom in and you see something like this, where there are hundreds of points right here, and here's the scale. So that's maybe 50 meters. That's a bird that nested. That's where Dakota nested that first summer that she went back to the Arctic. And we've been waiting for that, and it's happened 10 times now. So we have good data again on how these birds use the breeding area. And of the 10 nest locations we've encountered, 7 of them have been over here in the Ungava. And surprisingly, this past summer, 4 of the birds that we have nested, redwood, Yule, Dorval, and Simcoe, all had nesting data that we had to go along with it. So the other thing that we've been getting from all these birds that go back to the Arctic and then come back is looking at where they spent their summers multiple times. So here's 2 owls, Stella and Pettibone, that, whoops, that didn't work the way it should. There we go. The difference between their 2018 and their 2019 locations. They didn't spend the summer in the same place. And we were fortunate, and Pettibone gave us data for where it spent 2020, and it moved yet again down to here. Now, the other 4 owls sitting here are a bird called Wells. And that bird, over the course of 4 summers, has spanned an area of 1,400 kilometers, almost 900 miles. So they roam around the Arctic every summer looking for those places where lemmings are abundant and they can potentially breed and raise a family. This is Wells, and I want to kind of give you an idea of the change here. And it's particularly interesting that she was an adult female when she was banded in January of 2017. She went up and she nested in the Ungava. The summer of 2018, she went that full distance of 900 miles further northwest and did not breed that year. In 2019, she didn't return as far north, and she didn't breed that year. Well, Wells' transmitter is getting a little old. She's been coming back and spending the winter in the same area near Montreal every winter. And this winter, for a while, we were worried that we weren't going to see Wells. And all of a sudden, the 1st of February, she gave us a little bit of data, and here I'm here. And her battery has been struggling to get charge off of the solar panel. Well, we got more charge, and the 1st of March, she dumped more data, and we got a rough indication of where she was in the summer of 2020. We have data through about the 7th of June. So we don't have enough data yet to really tell whether she bred and nested this year. And we're hoping that she'll get more charge on her battery with the lengthening days and the high sun angles. And before she departs in April back for the Arctic, that maybe we'll get the rest of the data that's sitting on her transmitter. Now, when you look at all of this, this is a map of looking from a different perspective than most people are used to looking at a map. The North Pole is right here. Here's Greenland. This was done by Eugene Potapov in his book, The Snowy Owl, and it's an indication of where the core area of the snowy owl population in the world is. And it's over here in this red circle. It's the archipelago of Arctic islands up there in Canada. Things are changing for snowy owls. They're a conservation target because of global warming and what we're going to see going on in the Arctic in the next decades. And for us, we're rather sort of count ourselves lucky that we've been able to get owls going into this Arctic zone. If you want to take other looks at our data besides Project SNOWstorm's website, we recently put all of our locations into MoveBank, which is an animal movement archive created by the Max Planck Institute in Germany, and gives us a lot of ways that we can share and use our data, as well as archive it in the cloud. So if one of our computers burns up, we don't lose everything. And at this point, by the end of this winter, we will have 500,000 GPS locations for snowy owls archived from the 8 years that we've been doing this. I want to give you an idea of what it looks like big picture here. Our data, when the birds go north, the furthest northwest they've gone is Banks Island in the Northwest Territory. Furthest sort of to the northeast would be Lougheed Island over in Nunavut. And then we've had a bird otter that went over to Baffin Island. So we really have our owls that are going to a wide geography in North America. And I started looking at it, and we're going to kind of group them up. We have what I refer to as the Angava birds, which appear to focus their wintering areas on the East Coast and the Great Lakes and the St. Lawrence Seaway. They go up and spend their summers in the Angava and then come back to the same areas roughly that they wintered the year before. Then we have what I've started calling the Prairie Group here, which they are birds west of Wisconsin in the prairies. Some of them may have come from the Great Lakes. They take a different route up into the high Arctic. They're the ones that really set our high Arctic limits to where our birds have been going. Then there's a small group of 4 owls here that for now I'm just referring as to our crossover owls, because while they originate where most of the Angava owls are, they go a little bit further. They decide to get past the Hudson Bay. They cross the straits and go up into Baffin Island. And it'd be nice to get more birds doing this, just to see how frequent this behavior is, and can you really start subsetting your owls. If you put all of these birds that have gone to the Arctic and back on the map, it looks like something like this. And what's interesting is that it appears that they avoid long crossings of the boreal forest. Owls in the prairies that are hopping across here, that's a relatively short crossing. Most of these birds here are getting up to the shores of Hudson Bay and trying to get across the boreal forest as quick as they can. Surprisingly, we have not had any owls go out into Newfoundland. But I don't want you to think that we know everything about where these owls are going in the wintertime and what they're doing. We know from other research of birds marked in the Arctic during breeding season that there are what we refer to as marine owls that spend their winter hunting waterfowl along the coast of Newfoundland, out on openings in the ice pack where waterfowl and gulls spend the winter. Then there are also what we might refer to as tundra owls, owls that don't come south. They stay up there eating ptarmigan and maybe chasing hares and things of that nature along the edge of the boreal forest. And until just recently, we knew our owls might do that. And we always hoped that maybe we'd get some data when one of them comes south. And that's happened. And in a couple slides, I'll show you that. This is to give you an idea that even though there might be some divisions between the two, that they're not always perfect. Here, this is Stella, who was marked on Amherst Island in eastern Lake Ontario, spent her summer up here in the Arctic, but then went back to northern eastern Montana for the winter. So she really changed her pattern from year to year. And here's another one that did the opposite. Pickford was marked in the eastern Upper Peninsula, went up, spent her summer around James Bay, and then went back to the Canadian Maritimes and spent the winter out there. So while you can show patterns, birds are individuals and will do different things. Well, this was our best owl from the birds that returned this year. This is Argus, who was originally banded in the Red River Valley in eastern North Dakota in January of 2019. Argus then went north and spent the summer way up in the Arctic, where the landscape looks something like this. I can't provide an image right from where Argus spent summer 2019, but most of the area up there is basically open tundra, some rises in elevation, lakes, wonderful place for a snowy owl. Well, when Argus wintered in 2020, Argus didn't come south of the boreal forest. Argus stopped in very southern Nunavut. So last year, we didn't get any data from Argus. We didn't know where he was or what was going on. We just figured it's another one of our owls that we got a year's worth of winter data on it, and then it disappeared. Well, then this winter, before this winter, Argus went back to the Arctic, roughly the same place, 100 miles, 150 miles from where it spent summer 2019 and back there in 2020, but then it came south. And when it came south, it crossed the boreal forest into southern Saskatchewan, western Manitoba, where the landscape is very different. You know, open farmland, grain fields, places where you might find rabbits, voles, prairie chickens, and waterfowl. When he arrived and hit the first data dump, he delivered about 20,000 locations. It was just one of those things that we were popping champagne corks. Here we had an owl that stayed north of the boreal forest for a wintered in the Arctic, and came south to tell us what it had been doing for a year. So we have a fair number of outputs. I'm going to try and go through real quick here. Things that have come from us. There's other people now who have learned that, you know, they can trap and move snowy owls away from airports. This is Project SNOWstorm from Frank Ujikowski in the eastern Wisconsin, the Fox River Valley. We make our data available to people to use, whether it be college students or even grade school students, to do things like science projects. The veterinary folks have done a wonderful job and published several papers. Because we're interested in movements, I'm not going to go much further into that, but we've learned a tremendous amount by the effort of the veterinary community, looking at all the owls that have been picked up in eastern US. Publishing papers, giving presentations, doing webinars. When we put this together, the idea was to get the data in a defensible way so that when we had this abundance of snowy owls, we could then look at the data later after all the chaos of the winter was over. And we have been fortunate to have a graduate student, Rebecca McCabe, who's working on her PhD up at McGill University, who has been going through our snowy owl data. And she's publishing papers. She's up to about her fourth or fifth one now, to pull all together the movement data, what happens when you move owls away from airports, looking at survivorship, and then models for how they use habitat, and get a wealth of information out of all the investment that people have made. This is an infographic from one of her papers that was just published. You know, talks about using these fancy transmitters and then looking at owls from the center part of the country and from the Great Lakes and from the Northeast. And really their behavior patterns reflect more what is offered to them from habitat and prey availability than anything like sex and age and composition. Males and females, juveniles and adults will do the same thing, and what they do is really reflective of the habitats that they're trying to make it through the winter in. Rebecca supervised a young student, Andrea Brown, who did an undergraduate honors thesis. Her paper just got accepted for publication in the IBIS. That came out literally earlier this week. So within a month or two, we'll have another paper out there. There's folks from Hawk Mountain, seasonal interns that have used our data to produce papers and add to their education. And all of this has added new collaborators to Project SNOWstorm and how we're going about things. It's really been a tremendous collaboration. People might say, what do you think you're going to do in the future? One of the things we're looking at right now is working with some folks in Maine, because they're having some conflicts in Acadia National Park with hikers and dogs off leash on the tops of places like Cadillac Mountain. And they see snowy owls up there every winter. And we may work with them, if the funding becomes available, to transmit a few owls up on top of the mountains of Cadillac Mountain and Acadia National Park. And what we think the birds will do is go hunt waterfowl at night in the coastal areas, and then they spend the daytime up on top of the mountains. But we can also look at the impact of human disturbance by winter recreation on the mountaintops. So all of this, we are indebted and very grateful to all the people who have made these small donations via crowdfunding, and all the people who have worked on it. We are all volunteers. None of us make a direct salary in what we do with Project SNOWstorm. We do this because we're interested in snowy owls, and we want to learn about them so we can do better conservation. This is the core group at one of our meetings that happens to be in Cape May a few summers ago, and we thank you all. I think we're going to run by questions here, and Lily, we got time to make the video work?
Sure, if you wanted to share that, we could go ahead and watch that and then do the Q&A afterwards.
Okay, let's see if we can make this work.
This is the snowy owl, something of a mystery to science. Carl Linnaeus, the guy who was really good at putting animals into categories, didn't realize that females and males were the same species. Ornithologists still bicker about where snowies belong in the owl family tree. Because they breed in the frozen north, we don't really know how many of them there are, how they live, or if they can adapt to a warming world. But we may soon have some answers. In 2013, the United States was surprised by an invasion of snowy owls. There was an abundance of lemmings to eat in the Arctic that summer, and so lots of owlets hatched. They spilled down into the United States by the hundreds, then by the thousands. Sightings were reported in Virginia, Alabama, South Carolina, even Florida. This was a once-in-a-lifetime chance to learn the secrets of the snowy owl. Scientists trapped dozens of visiting owls.
Hold still.
And fitted them with solar-powered backpack transmitters.
Oh, she's awake now. Got it. And you're about to get let go.
They called the operation Project SNOWstorm. Among the tagged owls was a young male named Baltimore. He had hatched way up in the Arctic the previous summer. His mom had kept his egg warm for a month while his dad brought her food. When he hatched, he was an ugly ball of fluff. His dad now brought him food too, and his mom chased off hungry foxes. He grew quickly, learning to hop on strong legs and then fly. He migrated south, finally stopping at Martin State Airport in Baltimore, Maryland. It probably reminded him of the wide tundras of his birth, but planes regularly kill owls, so humans caught Baltimore, gave him a backpack, and released him on a remote beach. Over the next year, Baltimore carried his transmitter to the northern wilderness of Canada. It logged thousands of data points, the most extensive log of a wild owl's movements ever recorded. You might say Baltimore is the best known snowy yet. And so I decided to bundle up, take that same trip, see the things that Baltimore saw, and maybe meet him up in Canada.
So I packed my lunch and I gave my boss the slip. Wrote myself this theme song, going on a field trip, yeah.
This is the exact spot where Baltimore began his journey. And so, a year later, that's where we started our trip. Baltimore's backpack transmitter had recorded his location down to the meter every 30 minutes, and every few days, it uploaded that data via cell towers. We followed the data points up to New Jersey, where he had rested on empty summer homes. And we started to run into people who knew Baltimore.
Baltimore was a brave bird because he hung out in one of the most important bald eagle spots. Bald eagles are the only things here that snow owls are scared of.
It was very sunny that day. I came across this white bird body. As it turns out, it was Baltimore, just enjoying the sunshine, and I was enjoying watching him.
And then on to New York City.
What I'm thinking, just by working here, he must have been amazed by the noise, the height, the lights. It gets no better than this. Look at this.
So this is where he was. On and on he went, across Lake Ontario and into Canada.
They flew right on that top of that mast up there. You remember that, Di? Snowy owl sat right up there, flew right up on the mast there.
Oh, yes.
Yeah, that was quite a sight, wasn't it?
Baltimore stopped at Amherst Island, then headed north to summer in the Arctic. Come winter, he returned to Amherst, an island where they're crazy for owls.
Happy spring, everyone. 12 snowy owls were present the other day. Well, they're still here.
That's quite a bunch.
That is quite a bunch because we got 20 on the Christmas count and we had 25 searchers out. The wonderful story of Baltimore, right. I spotted the white owl on the very top of CJAI's silo. His mouth was open. You would swear he was laughing at us. Baltimore was hanging around the radio station and around the school.
We went outside and then the snowy owl was just like staring at us.
But we couldn't find him either of those places. Spring has arrived, and there's a chance Baltimore could have already headed north. His last set of locations were scattered across this 17,000-acre island, but those data points are 3 days old.
See a little white dot? It looks pretty good. It's like a big white male. It could be Baltimore.
I don't see a backpack. Oh my gosh, look, that's Baltimore right there.
We're never gonna find this owl. Oh, and is that one out in the field? Every time I see a mailbox, I think that's an owl. Oh. Yeah, that's him. I can see the transmitter. I think that's him. I think that's Baltimore. Right there. That's really him.
He's looking at us. There he goes, the owl whose secrets aren't so secret anymore. We now know he loves to hunt at night, that he likes to eat not just voles, but water birds. We know that he can reach speeds of 55 miles per hour, fly 140 miles in a stretch. We know the altitude of his route and the places he likes to stop on his 1,600-mile migration. All his data, along with data from other owls, is helping to answer our questions about this mysterious species. Maybe that new understanding will help us protect them. This year, Baltimore turns 3. That's the age when we think a snowy owl first seeks out a mate in the Arctic. And as he flies north into this new chapter, we will be able to follow.
Morning star lights the way, restless dream all done. Shadows gone, break of day, real life begun.
If Baltimore survives his summer in the Arctic and returns to cell range, he'll bring with him a whole new set of data. Data that tells the story of frozen hunting grounds, and perhaps a nest full of owlets.
Going home, I'm just going home. It's not far, it just comes by through an open door.
This is the snowy owl, something of a mystery.
Uh-oh.
Okay, Dave, thank you so much for that incredible presentation.
Yeah, I got to figure out how to stop this.
That's all right. We're not hearing it on our end here.
Well, that's
so we're
good.
going to go ahead and get started with the Q&A. Our first question comes from Noah Stryker of the Things with Wings. And he says that snowy owl eruptions are not based on lemmings availability, but simply wanderlust. What are your thoughts on that?
Oh, I kind of politely want to disagree. The big invasions are years when many, many young are produced, and these young have to survive to adulthood, and so they come south in what is pretty much now accepted as a normal migration. Come down, make it through the winter, and then if they survive, eventually go back to breed.
Okay, and question number 2. Is there a universal GPS transmitter for bird tagging, or are they built specifically for different species?
There's different sizes and weights for different groups of species would be the best way to put it. What goes into them, the guts is pretty much the same. What people vary is the size of the solar panel, the size of the battery, and then you have to make a case that is usually specific for the bird you're putting it on. Now, some birds, you can use the same transmitter on several species, but for the case of snowy owls, we made it in particular just for snowies. We've learned things over the last 8 years and have modified our case design to get better aerodynamics and better exposure of the solar panels. We're right on the cutting edge of technology with all this. Right now, the smallest transmitter that uses this technology is about 15 grams. The ones we put on snowy owls run about 35, 40 grams.
All right, next question is, it looks like the owls fly in very straight lines. Is that true, or is that just how the transmitted data appears?
That's an artifact of the data. We get a point every 30 minutes. And when you produce a graphic like this, you just draw lines in between the points. And you don't know where they were from a data standpoint in between. So yeah, it's an artifact of illustration that they look like it's straight lines.
What is their biggest prey?
Depends on what you mean by biggest. There's records of them taking things like great blue herons and geese, which might be the largest body-wise. If you're talking about number of items, it certainly is lemmings in the Arctic. But they are a generalist predator. They take all kinds of things. Birds along the coast tend to focus on water birds. Birds in the prairies focus on things like rabbits and grouse and meadow voles.
And what is their wingspan?
About 4 to 5 feet, depending on whether it's a male or female. Probably more like 5 feet. That's not something we typically measure.
All right. And there was an amazing photo of the lemmings stored around the eggs. Can you expand on their diet and the piling up of the lemmings? I've never seen that before.
Part of the behavior in courtship is the male will be feeding the female to prove that he's a good provider, and they will bring back lemmings. And when you have a spring like they had in 2013 or a summer, he just wants to make certain she knows that he's a good provider, and he keeps bringing back lemming after lemming after lemming. Now, ecologically, that is to the benefit of the pair, because the more he can courtship feed the female, the better condition she's going to be in, the higher her body weight, so she can lay a large clutch of eggs. And then as long as the male can keep providing lemmings, you have plenty of food for this growing brood. And clutches can be up to 7 or 10 eggs when you have these big lemming pulses. And that's a lot of lemmings that you got to provide. So that's why you see that nest. That was part of courtship feeding, the male providing all the food he could. And of course, in the Arctic, it's cool, so they don't decompose readily. And whenever female was hungry, she just picked up one of the presents.
Wouldn't it be nice if humans did that? Next question is, I wonder about Island Beach. Any idea if there are snowy owls at that site?
If you go to the SNOWstorm website, one of the owls is named Island Beach. It was trapped near there, and we have some telemetry data from that bird during that winter. I think it was 2017 when Island Beach was caught. But Island Beach State Park is a known place where snowy owls are regular many winters.
Right? And how can people like me, who have no expertise or training whatsoever, but a huge interest in these gorgeous birds, assist with their study and protection? Are there any citizen science opportunities, and how would we find them?
The citizen science that I know of would be contributing to the wing and tail photo archive. You know, if you can take photos without disturbing the owls, or if you're watching an owl and it gets flushed by an eagle or decides to just change its perch, you get good wing photos. You can put those onto the Project SNOWstorm website. The more important thing that people can do is climate change is impacting the Arctic. And when people say, what can I do to help with conservation? Our answer is always think about your impact on carbon cycles and what can you do to live more softly and try and do what you can to reverse the trajectory of carbon accumulation in the atmosphere. Because if snowy owls and polar bears and walruses are going to survive and other Arctic creatures, we need to do everything we can to reverse or change the trend of a warming climate because of our carbon budget.
I had gotten I had gotten a Project SNOWstorm sticker for my car a few years ago, but traded in the car and lost the sticker. Is there a way to buy a new one?
I sort of wish there was. I mean, we've had various perks when we were early on in the crowdfunding process, and it takes a lot of effort to get those made and distributed, but they're unfortunately all gone now, as are the t-shirts and many other perks. And we just don't have the time to manage that end of it. So unfortunately, your sticker went with your car, and you know, maybe sometime in the future, someone will say that what they want to do to help is manage something like that to help fund the research we're doing, and that's one way that maybe some of those perks could come back. But right now, we all focus on the work of running Project SNOWstorm by putting transmitters on owls and managing the data.
All right. Who is involved in snowy owl research in Cape May, New Jersey?
It'd be the folks primarily from Cellular Tracking Technologies, Mike Lanzone, Trish Miller, David LaPuma. When we have owls in New Jersey, and now the way we're moving is we're tagging more and more adult owls because of what we can learn about their time in the Arctic. So if adult owls come down, you know, then we'll be attempting to put transmitters on there. But right now, it's been a pretty quiet winter in Cape May this year.
How long do snowy owls live?
Longest known snowy owl is like 27 years old.
Is that normal, or is there an average?
Average is probably more like 15, 10 to 15. There's a considerable mortality bottleneck that they go through as they're learning to hunt, migrate, survive that first year. So probably 60% of the young birds don't make it to a year old. But once they get through that bottleneck, their survivorship goes up, and they will easily survive into their teens.
And do they typically migrate to the same places year after year, or does it vary?
It depends on how tightly you describe the same place. Some of our owls are really fixed on come back to the same area. Wells is a good example. I mean, within 20 to 40 or 50 miles, he's in the same place all the time. But then when you look at like Argus, which stayed north of the boreal forest last winter and came south of it this year, it may stay in the same flyway, but could be, 100, 200, 300 miles away from where they were the year before. So like people, they're individuals. We initially thought that, they moved around a lot winter to winter, and more it's looking like once they're 2 or 3 years old and they have a tradition, they seem to follow it. But it takes a while for them to find an area they like to winter and then start coming back to it within a reasonably small area, let's say 50 miles.
Do they mate for life?
We don't know the answer to that. Probably not, because they show so much nomadic behavior and moving around during the Arctic in the summertime. Think of an owl that comes down and winters along the St. Lawrence that might have been paired with a bird that wintered in the Canadian prairies, and then having them go back to the Arctic, find each other, and then wander around and find an abundance of lemmings. It's more likely that they repair every time they breed, because for some years, like Wells hasn't bred for a couple of years. So I suspect the answer is that they don't, but I can't prove it with data.
Is it dangerous to post tracking locations in real time because people could bother the birds?
We don't post tracking locations in real time for exactly that reason. We put tracking locations on our website, but they are delayed by at least 3 days. And there's an algorithm in our website that if an owl is being too much of a homebody and using a site too regularly, that we lengthen the delay before locations are posted.
What preys on snowy owls?
Wolves, maybe golden eagles, got to be basically pretty large predators. You may have Arctic foxes taking chicks up on the tundra. I suppose a polar bear, if it could, surprise one, might take it. But there aren't a terrible number of predators that snowies have to worry about. Probably the biggest ones are the large eagles.
How can we keep learning more about Baltimore? Where is he now?
Baltimore's transmitter failed after a couple years, and it took us 2 years to recapture him, but we knew where he was coming back every winter. So we eventually captured him and removed his transmitter. He's out there, and the only mark he's got left on him is a leg band. And hopefully he lives a long time.
When do snowy owls return to the Arctic for summer?
Beginning in about mid-March, the adults, many of them are gone by early April. Young birds that aren't old enough to breed may stay towards the end of April, but generally, other than the rare bird that, is a behaviorally abnormal, most of them are gone by mid-May.
Where do most of the snowy owls in South Jersey migrate north to?
Probably the Ungava. They're mostly that group that is staying east of Hudson Bay. And if I have to generalize, that's where I'm going to peg them to.
Who is involved in research in Edwin Forsyth National Wildlife Refuge?
That was folks associated with us. It was Scott Weidensaul going east, and probably had Mike and Trish Miller up trying to mark a bird there. There's Northside Jim does a lot of photography along the coastal New Jersey, and so he may be taking photos of them. But that's the extent of what I know of that's going on in Forsyth.
We had a snowy owl for weeks here in the peninsula of Bayonne, New Jersey, that was named Ukpik. Should we have called Project SNOWstorm?
You could have called us. I don't know if we would have been able to mark the bird or do anything about it. There's owls all up and down the coast here. This year, because of the pandemic, we really restricted our trapping. Basically, when people are interested in getting an owl marked, sponsored owls are always things we try and take advantage of, because this is a crowd-funded effort. The difficulty is to mark an owl, you got to have somebody with the skills and the permits nearby. And when we can, we do our best to take advantage of those opportunities, but we can't always make that happen.
Okay, and we'll do one last question here. How are the counts since the eruption in 2014? Are they on the decline or endangered?
They're so eruptive and the numbers are so hard to gather that it's really difficult to say whether they're stable or declining. If they're increasing, it may be short-lived and related to changes in the Arctic weather that benefit lemmings. But that's a really difficult question to answer. And basically the data isn't there. Maybe the best attempt might be to use eBird data over time, but that takes a time series of data that's at least 10 years long. So jury's still out on where we are, but we're generally concerned. We don't expect them to be increasing. We expect them to be stable or decreasing.
Well, that is all we have time for today. Thank you so much for taking the time to be with us, and a special thank you to you, Dave, for putting together this awesome presentation. And for everyone else, we will be sending out a follow-up email with the recording from today. Have a great day, everybody.